Hello, this is Dr. Mears. Today we are going to be going over geometric series, diverging, converging, and the sum formula. First, some vocabulary. Geometric sequence. Each term after the first is found by multiplying by a non-zero number called a common ratio. So we're multiplying by a number, the same number every time, and that's why it's a common ratio. Then we have diverging. Diverging geometric series is if the absolute value of each subsequent term is getting larger, meaning going away from zero. So if you look at the pattern and it looks like it's going to be increasing, then that's going away from zero, and that's what diverging means. So going away from zero is diverging. We can test our ratio if the ratio is less than -1 or it's greater than 1, then we know that we have a diverging geometric series. We can also look at it and look at the numbers and tell. So you don't have to get too technical here. So example of diverging. First, let's just look at the numbers and see if they're getting bigger or smaller. So we're going from 1/3. If we do 1/3 in a graphing calculator or any calculator, we're going to get 0.3333 repeating. Okay, plus, now we do 2/3. Well, 2/3 is 0.666 repeating. Okay, and then we're going to do 4/3. 4/3 is 1.33 repeating. So just changing them to decimals and looking at the numbers 0.33, 0.66, 1.33, we know we are going away from zero. So just by looking at it, we know that it is diverging. However, if we wanted to test it to get a little bit technical, what we're going to do is we're going to take this first number, 2/3, and we're going to divide it by this first number here. It's 2/3. Did I say first number? I meant second number. This second number, 2/3, and divide it by the first number, 1/3. There we go. Now, when you do this in a calculator, I would like you to put parentheses around the fractions because it makes sure to tell the calculator that we're working with fractions. So bringing out your calculator and turning it on, what we're going to do is parentheses 2 division sign 3 end parentheses. We're going to divide that by parentheses 1 division sign 3 close parentheses. And we're going to get 2. So this equals 2. Now this is our ratio. That's how you find your common ratio. We've been doing that. And so 2 is definitely greater than 1. So we know that this is diverging. Okay, 2 different ways of doing it, either way you would like. Now, a converging geometric sequence, if the absolute value of each subsequent term is getting smaller, so it's approaching zero. And we can test our ratio here, and we actually have to take the absolute value of the ratio. So if we're getting smaller or going towards zero, it's converging. So first, let's just look at the numbers. We have 20 plus 10 plus 5. We are definitely getting smaller here, so you can clearly see it is converging. However, if we need to test using our ratio, then we're going to take this second number, 10, divide it by our first number, 20. That is how you usually find your common ratio. 10 divided by 20 is going to be 1/2. Actually, let's write that, 1/2, which is equivalent to 0.5. So now to test it, we have to take the absolute value of 0.5. So the absolute value of R. Absolute value is the distance a number is from zero. So how far is 0.5 from zero? Well, 0.5 from zero is 0.5. And we have to see if that's going to be smaller than 1. Well, is 0.5 smaller than 1? Yes, so we see that it is converging. So it is absolute value. A lot of people like to think, well, when I'm taking absolute value of a number, it's going to be positive, and you are right. But the number is positive is because it's just how far it is from zero. Okay, let's look at some examples with the sum formula. So we went over converging and diverging, and let's see what we have here. First, a note, you can only take the sum of a converging infinite series. Here is our geometric sum formula. The sum of infinity, all of the numbers added up to infinity, equals u sub 1, which is the first term, divided by 1 minus r. So u sub 1, remember, is that first term. and R is going to be our common ratio. And we are going to have to check, this is the first thing that we're going to have to do to make sure it's converging. And if it's converging, then we can do the second step. If not, we stop. We don't do the problem anymore. So let's do this example. Decide whether the infinite series are converging first. If so, find the sum second. Okay, so let's look at this one. What we're going to do is we're going to take this first, nope, I keep doing that. We're going to take this second term, negative 1/8, and divide it by the first term, 1/4. Notice that I put it in parentheses. This is how we usually get our common ratio. I'm going to move the paper over a little bit. This is how we usually get our common ratio. So let's take our calculator out on. So we have negative 1 divided by 8 divided by 1 divided by 4. And we are going to get negative 0.5. So our ratio here is negative 0.5. But we have to check to see, make sure the absolute value of that is greater than 1. So we have to get the absolute value of negative 0.5. How far is negative 0.5 from 0? You're right, it is 0.5. We have to make sure that that's less than 1. And 0.5 is less than 1, so we are good to go. We know it is converging so that we can now go to that second step and find the sum. So what you're really doing here, because you know this is going towards 0, what you're doing is you're going to be adding up all these numbers and these little numbers here too, because this series keeps going on. We only see the first few terms. So we're going to be adding up 1/4 and minus 1/8 plus 1/16 all the way to 0. And we want to find what that sum is. If we added it up from here all the way to 0, what that sum would be. So let's find it. So the sum of this infinite series equals u sub 1, 1/4, divided by 1 minus r. Now let's go back and circle r because you have to be careful. We are using this negative, so it's going to be 1 minus, and I'm going to do in parentheses, negative 0.5. And you could do this one of two ways. So one, make sure that's a negative 0.5. So you can do this one of two ways. In the calculator, you can do this entire thing in the calculator, but you have to be careful because you have to keep the denominator together. And what I mean by that is you're gonna have to use a second set of parentheses here. And I know that we're using parentheses everywhere, but it just keeps everything separate. So I'm gonna do parentheses 1 divided by 4, so that's together. And then divided by, so this next division symbol, that's that big one. And now I want to make sure to tell the calculator, all right, this is the entire denominator. 1 minus negative 0.5. Notice how I have that in parentheses, and now I have to end this second one. And I press enter, and I get a decimal 0.1667. I can change that into a fraction by pressing math. And see how it says frac here? So I'm just gonna press enter and enter. I do have a TikTok on that. You can follow me. It's at Dr. Mears. At Dr. Mears. If you would like to go over that, I believe it's a 30-second video. So you can check me out on that. All right, that little promo there. Let's get back to this. We turned our 0.1667 into a fraction, 1/6. So when I add all of these numbers up all the way to 0, my sum is going to be a small little 1/6. Get that, huh? All right, let's keep going. Now I have this one. This one I have to do a little bit more work on because we have summation notation. So we're going to be taking this part of the summation notation and we have to substitute number 1 in. Yes, they started at 1. Now it goes from 1 to infinity. That's because it's an infinite series. So here we have to find our first term and we have to find our second term because remember we have to make sure that it is converging. So first let's do our first term. So I'm going to put this 1 in for our n. So I'm going to get negative 2 times negative 1 divided by 3 raised to that first power. Now, if you are confused, it's okay because all you need to do is put this in the calculator just like you see it. Making sure, here is this negative symbol. Here's the 2. Making sure you use parentheses. Making sure that -1 is there. Here is your exponent button right above the division. Press your exponent button. You can put a 1 in. Press enter. We have 0.6667. I don't want you using the decimal because it's only an approximation. I do want you to press math, enter, enter to make it into that fraction. So we get a 2/3, okay? Math, enter, enter makes it into that fraction. So the first term is 2/3. Let's find our second term. We're gonna do -2 times -1/3 raised to the second. So you take the next number. After 1, it's 2. So we're gonna put 2 in. Then we're gonna take our calculator out. -2 times -1/3 raised to the second power. Again, I get a decimal. I don't want a decimal. I want the actual approximate answer. So I'm going to press alpha. Nope, no, not alpha. My bad. Math, enter, enter, and I get -2/9. So changing it from that decimal to that fraction helps you get helps you get the exact answer. This is the exact answer. If you use the decimal and round it, you're going to be off in your answer. It's only approximation. So that's why I want you to change it to that fraction. All right, so first we're going to have to make sure that this is going to be converging. So let's take this second one, -2/9. Divided by the first term, 2/3. You can do that in the calculator. We just did that. We're going to come out with an R of -1/3. But in order to make sure to test it, it's going to be -1/3 absolute value. So the distance is 1/3, which is positive. 1/3 is 0.33, which is definitely less than 1. We know that it is converging, and we can move on. After we found out that it's converging, that was our first step. We're going to go to the second step, and we're going to take the sum. So now we have to find, if we started at 2/3 and we kept putting the numbers in and added all of this up, what is the sum going to be? So the sum says, use my first term, u sub 1. I got that, 2/3, 2/3, divided by 1 minus, and notice how I put the 1 in the minus. I'm going to go and I'm going to circle my actual common ratio because I need to use this negative now. Parentheses, -1/3. You can put this all in the calculator if you use parentheses around the outside of the denominator. However, if you get confused with these parentheses, you can do it another way. The other way is just by doing the denominator first. So if you just want to take care of this one, so we're going to turn this on. So if you want to do 1 minus -1/3 and get 4/3, so I transferred it from the decimal to the fraction. So this would be divided by 4/3. So I just did the denominator first, and then in your calculator, you divide the numerator by the denominator. Oops. 2/3. 0.5, and we know that 0.5 is going to be 1/2. So we found our sum. So if we started at 2/3 all the way over here, and we added them all up all the way to 0 because it's converging to 0, we would get a sum of 1/2. So this has been Dr. Mears. This has been diverging, converging, and using the sum formula. I hope it helped. Thank you.